Okay, this is Techmath2. We're doing the final review, and this is the last video I'll be making for you this semester. The Star Wars trivia that I'm going to do is all about an elegant weapon for a more civilized age, the lightsaber in Star Wars. The sound, Ben Burt made this very distinctive sound by basically getting an old television and a projector, an actual movie projector. That's the hum and the, not the crash, that's just like a little electricity crash, but it was backfeeding static against like a TV monitor is how he made the distinctive lightsaber sound. And at the end of the video, I'll tell you another little piece of trivia. So I got to turn on lights though now so you can see what's going on. Okay, so we're looking at the final review. It actually starts on page 4 of the final exam review. Remember, we did chapters 1 through 10 already, and so this will be chapters 15 from the Techmath 1 book, and then jump back to 11, 12, 13, 14 from the red book. So we're going to highlight the 20 problems that are going to be on your test, on the last test. All right, so write as a log equation. So what we have to remember when you're doing logs is it's just a fancy way of writing exponents. So when I have log, log, that's base 10 of 100, that's equal to 2. And so you'll see this all over the notes. I said, remember, log base 10 of 100 equals 2. That's the way that I memorize where the pieces go when you remove the log. I have 10 to the second power is equal to 100. And so you can see, like, the exponent is always over by itself. The base is always the lower number right there, the 10. And then that number gets shifted over to the other side of the equal sign. So you'll see this little, with a little remember, all over the worked out packet that I posted about the final exam review. All right, so let's do it here. Oh, there is a mistake also on the answer key. They changed the 185 to a 182 by accident. If you check really carefully, students might say, well, why is that 182? What happened? They just wrote the wrong number. So it should be 185. All right, so let's do it. We got, we could rearrange it so it looks like this first. 10 to the 2.6, 2.2672 is equal to 185. So now it looks like this, and we want to make it look like that. So we do log base 10 of that number should equal that power. So logs are just a fancy way of writing exponents. And so that's it. That's the answer. If you want, you don't have to put the 10 there. Log of 185. And I think on my key I put parentheses there. That's not a requirement. It's just a habit. It is if it's a binomial or something, then you definitely have to have parentheses. But if it's just a number like that, you don't need the parentheses. All right. So either one of those, right as a power of e. So when you have n, that's really just this, log base e of 9.31 is equal to 2.23. And then this still works, same thing. It's just e, the 2.23 power is equal to 9.31. That's it, done. All right, given b is equal to k times e to the negative ct power, find b. Okay, so find b. So this is really just a calculator problem. Be careful, I don't want you losing any points on one like this. E to the negative C 7.2 times 0.096. So if you are putting it all in your calculator, just as one shot, you do 485, then second ln, that'll kick up e to the, and I'll put a parenthesis. And then, yeah, you could just write negative 7.2 times, without this in there, times 0.096 end parenthesis, and then hit enter. And then they want it to the nearest whole number. Or, I'm sorry, they want it to, which one is this here? Number 3. Hold on, what did I do? Oops, that's number 4. Sorry, I'll have to go back and do number 3. 3 was also just plug and chug in that calculator. So let's make sure I got these right here. That's 1, that's 2. Okay, yeah, so this is 4. Sorry, I jumped to 4. So that's 242.9726. That is 243. That one they want to a whole number. All right. So now we will jump back to number 3. Sorry. Number 3 is on there also. Okay. So number 3 is given h is equal to d over t to the 0.6 power, find h. When d is equal to 47.6 and t is equal to 61.3. And that one they want round to thousands. So again, it's a calculator problem. Do a parenthesis, 47.6 divided by 61.3, end parenthesis to the power 0.6. And just hit enter. 0.8591, 873752, and thousands, so 0.859. Number 3 is that. Okay, so that's 1, 2, 3, and 4 are all on the test. All right. Then we go to chapter 11. And 1 is, look, if y is equal to 5 sine theta. I have to make that 5 look a little better. Then what's the amplitude? And what's the cycle? How many basic cycles are there? And then that's 1 is on there, then 2a and b are also on there. And so that is, this one they want you to write an equation that has amplitude of 12.6 and is in phase with y equals sine theta, and b is amplitude of 18 and 5 cycles between 0 and 360. So remember, the thing about sine waves, one complete cycle, meaning when does it start repeating itself? You go up, you go down, you go back up. Right here, that's 360 degrees. That's considered one cycle, because after that, it's just the same thing again. And then the same thing again, and the same thing again. It's cyclic. It just keeps going again and again and again and again. So when we say, hey, the graph of y equals 5 sine theta, the amplitude is 5. Amplitude is this high point. It's how far up does it go from the positive x-axis, or just the x-axis, whether it's positive or negative. So look, this, if there was a 5 in there, it would go up as high as 5 and down as low as -5. That's called its amplitude. So the amplitude is always just a number in front of the word sine theta. How many basic cycles? That's the number in front of here. If there's a 10 there, then there would be 10 basic cycles. If there's nothing there, remember there's a 1 there. So that's 1 basic cycle. So the answer is 5 for the amplitude and 1 for the cycle. If the amplitude is 12.6 and it's in phase with that, that means 1 cycle. So that's just y equals 12.6 sine theta. And we're done. And amplitude is 18, 5 cycles. So that's going to have 2 things going on. It's going to be 18 sine of 5 theta. And that you could put in parentheses, or if it's just one number like that, you could just leave it 5 theta. All right. So those are the answers for the first page of the notes that I copied off. So that's chapter 15 from Techmath2 book, the blue book, and chapter 11 from Techmath2 book, the red book. And so now we're going to do chapter 12, and we're going to start 13, but then I'm going to end the video and do a second part. So this will be a 2-parter video. Okay. Hopefully everybody's healthy at home and not working too hard. All right, so let's take a look. This is chapter 12. They want me to convert to a power of 10 equation. So same thing as before. They got the log A is equal to B. And again, I'm going to have this on, log base 10 of 100 equals 2. The base, they're asking, what do I take this power? I take this to what power to get that? So that's 10 squared equals 100. So when you're doing logs, it's just a fancy way of writing an exponent. So if it's in a log already, we'll add the 10 there. You could take it out, B equals A, and write it as an exponential equation, or a power of 10 equation is what they call it. All right, let's look at 3. Solve for t. Ooh, this one is difficult. This one might be a win as the hardest one on the whole test. Let's see here. So solve for t and round to hundredths. And we have 500 is equal to 2t. So let's take that. And here, I'll work over here. We'll rewrite it. 2t is equal to 500. So it looks exactly like that. And then we're going to go log base 2 of 500 is equal to t. Well, now here's the rub. This is why this is one of the hardest ones on the test is you have to use the change of base formula. In your calculator, you only have base 10, log, log, or base e, that's the ln, the natural log. And so we don't want either one of those. We want log 2. I guess if some of you have a fancy enough calculator, it'll let you put that in there, like the 2 and the 500, and just hit enter. But in case you don't, most of you don't. Most of you just have like a standard TI graphing calculator, like 84. You do the change of base, which is this. Log base 10 of the 500 divided by log base 10 of the 2. And that will give you the answer for log base 2 of 500. And so to type that in your calculator, you just hit the log button, the log. You'll throw a parenthesis on there. You go 500. And now this is very important. Remember that end parenthesis. And then you hit the little divided by key. That'll be a little slash. And log of 2. And that one, it doesn't matter if you forget that in parentheses, you just hit enter. And so when we do that, we will get 8.965784285, and they only want it hundredths, so 8.97. All right. So be careful to remember this. Every year, anybody who messes that up, that's where they mess it up. They forget to put that in parentheses for the change of base formula. All right. So we're going to do 4. Ooh, I made up a new one, 4.5. And then we're going to do chapter 13, 1B. And I made up one for there, too. Oh, chapter 15 is gone. That was in chapter 15. That was chapter 12. Alrighty. Alright. So here goes. We got number 4 is solve for n when we have k times log a to the nth power is equal to p. So this is really just a one-step problem. You just have to do one thing here. When you have logs raised to a power, they have a rule that you can take the power off of the thing, log of a number to a power. That power you can pull down in front as a multiplier. And so this becomes n k log a. So the a stays there, just the exponent can be pulled down front as a multiplier. Equals p. And so now it's just a one-step equation. You just divide everything that's not n k log a. And you're done. So n is equal to p over k log a. Done. All right. Then I made up a 4.5. I don't know. I think this is a little overkill on my part because I think everybody that's watching this video will be able to do this one pretty easily. It's an equation. They give you an equation like this, 20 log e sub 2 over e sub 1. And that's what d is equal to. And then they just say find d when e sub 1 is equal to 0.03 and e sub 2 is equal to 14. So be careful not to sub them in the wrong order. I guess that would be the mistake. Most everybody got this right, but I think if anybody did get it wrong, they just put those in the wrong order. It's 14 over 0.03. And you just type that into the calculator. So calculator problem, it works out to be 53.38013562. And I want to the nearest whole number. And so d is equal to 53. So that was another one that I made up. Oh, actually, that was the first one that I made up for you. But I made up a couple. 2 more made up ones. You know they're made up because I made it a decimal like 4.5. All right, so there we go. So make sure you can handle that one. Then it goes to chapter 13, 1b. Find r when the natural log of r is equal to 3.65, and it says around a tenth. So we're going to take this and pull it out of log land here. Log base e of r. ln is short for log base e. By the way, if you put your answer, if you need a log in your answer and you leave it log base e instead of ln, I'd still give you full credit. That's fine. Math people used to always write it log base e. The business people transferred it into ln. All right, so this is what? E to the 3.65 is equal to r. And so now you just type that again into your calculator. And that's 38.47 ... So we're going to call it 38.5. All right. 10th place. And then the last one I wrote here, I'm going to erase the top one here and write it up here. See it? Because it's a made up one. I want you to be able to see it good. So this is 1.5. I just made it up. There's one like this on the test. Convert to a logarithmic equation. And so what that looks like is e to the 9.2 is equal to 989,897. Sorry. And so we want to write that as a log. So again, we're just going to think about this. If I take the log base 10 of 100, that's 2, and 10 squared is equal to 100. So we're going to go from this back up into that. So we're going to say log base E, or 9897, is 9.2. And that's it. You can give me that answer if you want to be fancy. ln 9897. 9.2. That's fine. Either one. All right. So next video will be the last video that I make. It'll be the 3rd and 4th page of work for your final exam.